Um, David Breede. Currently, I'm the Program Executive Officer for Tactical Information Systems at Special Operations Command. It's a mouthful. I always have a very long title in front of my name lately, but I'm going to share with you today kind of a little bit of my background, my career path, how I got, and then maybe some things that hopefully you'll find a little interesting on what we're doing now here at the command and what I'm working on now. But if you want to quickly flip to the next chart, um, yeah. So and it's very small on my phone, and I don't remember everything I put on the slide. But personal. I've got two kids. I'm married. I live here in Florida. I grew up. I was a Marine Corps brat. Was born on Quantico, Virginia, on the Marine Corps base there. Spent 3 years in Ankara, Turkey. I lived in Ankara. My dad was a naval attaché officer at the embassy there, and for probably the first 7 years of my life, I spoke Turkish more fluently than I spoke English. But when we moved back here, it doesn't take long to lose it. So we moved back here. I grew up in the Stafford, Virginia area. Graduated North Stafford High School. Went to Virginia Tech, got my engineering degree at Virginia Tech, and ended up getting a graduate degree shortly thereafter in engineering from Southern Methodist University, and most recently got a national security strategies master's degree from National Defense University at the Eisenhower School. Um, I am 50 years old. I think in September of next year, I will hit my 30-year mark for being a civil servant with the Department of Defense. And that includes I think it was a 2-year break of service when I first moved down here to Tampa. I started my civil service career at 16. The Department of Defense has a science and engineering apprentice program. And in the summer after I think it was junior year, of high school, after my sophomore year of high school, I got to work at the Naval Surface Warfare Center in Dahlgren, Virginia, working on the USS Iowa investigation. And I'm not sure how many of you remember that, if you're old enough to remember that, but one of the last battleships that was in service for the Navy had an accident when it was deployed. One of the 16-inch guns exploded, and there were some fatalities and a lot of injuries. And they were trying to figure out exactly how that gun exploded. So for 3 months of my summer in high school, I got to blow up guns and figure out exactly how the accident happened. And we were just over and over again trying to find different ways to blow that gun up. And so not a bad way to start your career in the Department of Defense. I went to Virginia Tech, quickly got involved with their cooperative education program, which, after your freshman year, you start a cycle of going to school a semester, going to work a semester, and just kind of flip-flop that. So it took me 5 years to get out of Virginia Tech because of that schedule. But again, I got a job at the Naval Surface Warfare Center in Dahlgren, Virginia, working for the tests and instrumentation branch. Got to work on some cool things. How do you instrument a room so that you can tell if when you fire an anti-tank missile into a building, that even if shrapnel doesn't hit the people inside, the overpressure comes off the top of the building and does the job anyway. Or filming the yaw, pitch, and roll of a 7.62 millimeter round coming out of a Gatling gun, to see if there's anything you can do to make the flight dynamics of that round better. All kinds of different things. So in 1996, I graduated Virginia Tech, and because I was in that cooperative education program, was immediately offered a job as a civil servant with Naval Surface Warfare Center Dahlgren. Spent about the next 8 years working on an Aegis ballistic missile program. So I got to go out on Navy ships doing engineering work, for testing ballistic missile defense type systems. So a lot of flight testing of missiles out during NATO exercises in the North Sea. Spent a lot of time in Hawaii, actually, because a lot of the tests were done at the Pacific Missile Range facility, which is off the north coast of Hawaii. So spent a lot of time in Honolulu and Waikiki, but a lot of late nights at Pearl Harbor and over on Kauai up at the Barking Sands facility. So it's probably, I worked my way up. I think, when I was a science and engineering apprentice, I was probably at the GS3 level. So when I got hired out of college, I think I was a GS9. And work your way up to GS 9, 10, or 9, 11, 12, 13. And those of you who aren't familiar with, the government pay scales, those are just, how senior you can get. The GS scale goes up to 15 before you get into senior executive service. So I left Dahlgren at the behest of one of my neighbors. He would happen to be a direct reporting program manager for a Marine Corps program called the Expeditionary Fighting Vehicle Program, and had been bugging me to come over and be the system engineer over there for that program. So I did. I ended up leaving just to try something new. Was a system engineer over there for their test and evaluation branch. This was a platform that was supposed to replace the amphibious assault vehicle. It could carry, I think, 12 Marines in the back. It had a 30 millimeter gun on top. It also had 7.62 gun for self-defense. Could travel in the water at speeds up to 30 knots. It would hit the beach, transform into a tank, and then do, basically look like a tank as it's going over land. So a pretty cool program to work on. It didn't pan out too well. Ended up going through several what are known as Dunn-McCurdy breaches, but you end up going way too far over cost and schedule, and you get in trouble with Congress and you get in trouble with the department. And we ended up scrapping that program. I kind of saw the writing on the wall in 2006. And when I got a phone call from someone down here at Special Operations Command asking if I'd come down and run engineering on a technology development program for a high altitude, long endurance unmanned aircraft, which is one of the pictures down there in the lower right. I think it's the top picture underneath the picture of my daughter on her track team. If I'd help run that, I said, sure, what the heck? I'm tired of the snow and ice in Virginia, tired of the traffic on I-95. Let's try something new. And so we came down here. I've been here since, like I said, since 2006. I thought I'd be here for about 5 years. 2 years into the job down here, my boss offered me, a program manager job, working in the fixed wing portfolio for Special Operations Command. And since then, I took over and ran their strike program. So all of the next generation gunships, all of the soft unique munitions, for fixed wing platforms in 2014-15 timeframe. I was asked to move down and be the deputy program executive officer for special reconnaissance, which is a portfolio with a lot of different kind of sensors and small system support to intel collection. Took over as the actual PEO, or program executive officer, in 2016. And then we've gone through some transformation since then across the portfolio. And I think next I will get into what the portfolio looks like now. I'm a little sensitive to time, so I'm gonna flip through these charts relatively quick because I want to give you an opportunity to ask questions at the end about whether it's about what I'm doing now, as much as I can tell you, or about how I progressed in my career. So yeah, here's the chart. So I'm now, like I said, I run the Tactical Information Systems portfolio. You can see the mission statement there on the right, but it's really about doing rapid and tailored acquisition of sensors, command and control, platforms, and placement of those sensors, and all of the tactical communications that's required to get information back to enable special operations forces to conduct their mission, whether it's a reconnaissance mission, a surveillance mission, a strike mission, a partner force mission, training mission. Really all about that intel collection and how we move data around to support our SOC users. It is about and you can stay on this slide, it is about a $1 billion portfolio. So if I let myself think about it too much, it gets a little intimidating, but so I'm in charge of, and I have full control over about a $1 billion a year budget spread across different types of money, whether it's for research and development or procurement or sustainment of different types of systems. Our portfolio is broken up into 6 kind of primary lanes of effort. These 4 are your traditional special reconnaissance lanes of effort, starting with technical collection and communications. These are your small kind of unattended sensors for either observing targets of interest or tracking their whereabouts and seeing where they're going. We do blue force tracking, which is basically putting a GPS beacon on our own U.S. forces, so we know where they are, just in case if they get in trouble, we know where to go find them, go get them, and also to keep them out of danger. So if we've got airplanes coming in or long range fires coming in, maybe laying down some fire, we don't want to be doing it on top of our own forces, right? So it helps us kind of understand where people are on the battlefield. We do red force tracking too, so it's a little more your James Bond type stuff, where we will tag and track unwitting and unknowing things and people and targets of interest, so we know what they're doing. And then green force as well. So we have partner forces all over the world that we want to know, be able to deconflict in case they're doing something we don't want to get in their way or have them get in our way, so we keep track of them. And then we do some specialized communications that are kind of non-traditional, doing things a little bit different. I run the integrated sensor systems portfolio, part of the portfolio. That's really a fancy word for signals intelligence. So that's, whenever you have RF transmission, whether it's from a radar or from a radio or from other ways of communicating, this helps us kind of detect and figure out where those things are emanating. So just for example, if you have a system on an airplane that's flying overhead and you get some sort of RF radiation from what looks like anti-aircraft radar, you want to know where that is, so it points it out and tells the airplane go somewhere else. And other types of missions that maybe you can think about with those kinds of technologies. But we install it on airplanes, on our soft boats, on man-packable stuff where they can wear, put it on small unmanned aircraft, and we're now actually have put up a satellite this year that puts that capability up on a small LEO satellite. Next one, sensitive site exploitation. That's your special operations kind of crime scene investigations. That comes in after a mission. It collects information, whether it's off of people. We do fingerprint and iris scans, facial recognition, to know whether or not they may be on a national or international database for wanted terrorists, and so it helps with hold and release decisions. Or we're taking things off of cell phones or off of computers to gather information to kind of help build whatever that next mission might be for special operations. The fourth column there, it's our remote capabilities. So all of your small, very small to kind of medium-sized unmanned aircraft fall into my portfolio. And in addition to that, we are now, like I said, kind of experimenting with space-based capabilities. So I have the director, so Special Operations Command has a director for what's called your tactical exploitation of national capabilities. That person works for me. It's currently an Air Force Lieutenant Colonel, and it works across the department and across the interagency to figure out, okay, how's everybody using those big, exquisite national space capabilities to support, tactical operations for special operations. And then we've been building and launching small, very small kind of CubeSats into space over the last 6 or 7 years, experimenting with them, kind of figuring out how they could support the soft mission. The next chart, recently, I convinced my boss, and honestly had to convince my wife that this was a good idea because it was going to take up more of my time, but convinced my boss to let me take over the tactical communications part of the SOCOM portfolio as well, because for my eyes, everything that we need to do on that previous chart all relies on a fully networked and connected architecture for communications and pushing data from unattended sensors to unmanned systems all the way back to decision makers at an operations center. So I took over what we call transport systems, so pushing information over commercial and government-owned satellites, pushing computing garrison-type systems out to the forward edge so that you can have full connectivity to your headquarters networks, even when you are operating out at a forward disadvantaged place somewhere remote in the world. And then all of the tactical stuff there on the right side of that chart. So handheld radios, different type of man-packable or put them in your truck type radios, as well as all of the technology that's required to bridge all of the different kind of radios that we have across the department, whether that's push to talk, UHF, VHF type radios, all the way up to kind of like your Link 16, which is a tactical information network that the department uses to push different information across the net. Let's see. So that's the portfolio in general. When we talk about what are we doing next here at Special Operations Command, what falls into my lane, kind of what's this next generation of special reconnaissance. We operated, in Iraq and in Afghanistan, in the Middle East, for 20 years after 9/11, and not coming up against very high-end type of defensive systems, whether those are kind of jamming systems or air defense systems, those kind of systems that you would think like a near-peer adversary somewhere in the world would have. So someone like Russia, someone like China, even someone like North Korea, Iran, those types of countries that maybe are more technologically advanced than what we were coming up against in the Middle East. So we're talking about having to evolve what we did for 20 years. It was, and I use the term loosely because nothing is easy in this area, but it was easier, right? You could fly wherever you wanted. You could talk however you wanted. Communications weren't jammed. GPS wasn't jammed. You didn't have these complicated air defense systems. So a lot more standoff capabilities are going to be required, a lot more resilient types of communications capabilities to overcome those kinds of jamming environments. But for SOCOM, the counter-terrorism, counter-violent extremist organization mission doesn't go away, right? That's going to be a persistent threat across the world. And so we have to figure out ways to do that more efficiently. We do that through partner force integration. If you can imagine, a lot of the portfolio that I run historically does not include things that you want to hand off to partner forces. They tend to be tightly controlled technologies, but that doesn't work anymore. We're going to have to work by, with, and through our partners. And so we're going to have to figure out how to take similar types of technologies or capabilities and put them into a form factor where we're comfortable handing them off to partners, knowing that we may never get them back, knowing they may fall into the hands of someone we didn't want to have them. So those are kind of like our thrusts of effort as we're pushing forward into what kind of the next generation of this stuff looks like. Next chart. So I've got two primary, as I look across the portfolio, two kind of primary goals that we use as our two North Stars of what we're pushing everybody towards. The first one here is something we call collaborative autonomy. As we work for autonomous systems, you see, autonomous cars, you have automatic facial recognition type technologies in the commercial world. But autonomous drones where you can just buy these off the shelf on Amazon and say, to the crudest extent, hit a button and say take off, and it'll take off for you. You don't have to have hands on stick and throttle type of stuff. But building out that autonomy so that single platform, I can say, go execute a certain mission, go find a red truck over there, right? Hit a button, and a single platform can, pretty much autonomously. We've got the technology now. It will go over there, fly over there, go find a red truck, mark it, and then come back and tell you it found it. That's relatively current technology. You can do that. Then we start getting into what we call collaborative autonomy. So how do I get different platforms to execute a coordinated mission through the sharing of information and different information based on their perspective of the operating environment? How do I get these platforms to operate in a coordinated manner? Build on that, and now how do I get these platforms? One may be an aircraft, one may be an unmanned and autonomous ground moving drone, one may be an unattended sensor that got in place months ago. How do we get all of these different things to talk to each other? So how do I get an unattended sensor to say, detect when a window came open, transmit that information to an unmanned aircraft? It says, okay, window's open. Now I want to be able to go in and take a look inside that window. The unattended aircraft takes a look inside the window and sees something that he may have been looking for, transmit that back, and now have another action taken on a different system autonomously based on the information that was collected. So it's really all about the ability to contribute to and then benefit from a shared understanding across the environment from disparate platforms. We are working hard at that now. That's a big part of my portfolio. We work across the department with the Air Force, the Navy, the Army, special operations, plus academia. I have contracts and agreements with Johns Hopkins Applied Physics Lab. I have agreements and sharing projects with Sandia National Laboratory, with other national labs, with the University of Texas. So it's a big problem. It takes a big kind of community of very smart and driven folks to kind of solve this problem. But we're going after it right now. Next chart. This is the other one. So this is really understanding that where we used to be able to just fly in circles over top of whatever area we were interested in with airplanes, whenever we wanted. That's not a scenario that's likely to be prevalent in the future, where you can just fly a low-flying, loud, slow airplane over top and be safe doing it. So a lot of those capabilities we used to put on airplanes, whether they were cameras or other things, we're just not going to be able to do it the same way. So how do we leverage the space layer to be able to do those same types of missions? How do I take a sensor off of an airplane, package it in such a way that I can put it on a satellite and push it up to space? SOCOM doesn't have any real interest in owning its own satellites. There's plenty of people out there that are doing it, whether it's commercial or some of our partners in the Air Force, Space Force, Space Development Agency. What we're interested in putting those different payloads on board, and so we have agreements. I've got partnership agreements with the Space Development Agency and the Space Force, working with different partners across the government to be able to figure out how do we get a special operator who may be working with a team of 2 or 3 more people somewhere in the world where he doesn't have access to just normal communication systems. How do we give him access to all that great stuff that's in orbit around the world right now, and gather information, and so he has a better understanding of the environment around him and what he's doing. So a big thrust with us right now is kind of like that, what we call tactically taskable and responsive space. How does an operator pull out a cell phone and say, I want to see what's over the hill, maybe 3 miles forward, and then get a pretty responsive product back to his cell phone that shows him exactly what's over the hill based on imagery that was taken from overhead. That's not solved now. That's something that's ambitious for us, but we're working on that now. So another kind of cool area that we're chasing after. What is the next slide? Okay, I think this is my last slide. So it was probably about 5 or 6 years ago when my boss at the time took all of those unmanned aircraft and unmanned systems that used to be up in a different office, and someone else was responsible for them, and moved them down to me. And it's really so we can get a better, I guess, realization that all these unmanned systems and all these platforms are really just enabling, placement and access for these other sensors that were already within my portfolio. All of the unattended sensors, whether they're cameras or microphones or RF collectors or something else, they need to get to these places. So it's really about using unmanned systems to enable the rest of the special reconnaissance mission. And to do that, it's a lot about really advancing those unmanned systems in such a way that you enable autonomy through, very advanced algorithms, through communication systems that will be resilient in a competitive atmosphere, to allow that collaboration between different types of unattended and unmanned systems. So pushing automation, and I'll go ahead and throw it in there, pushing artificial intelligence so that it can observe and learn and then change behavior based on the environment around it, and then share that information with others that are on the network so that they can do the same. It's really optimizing that. How do I get the load off of a human operator, or how do I remove that human operator from where it's too dangerous for that operator to be, and I can push in an unmanned or unattended capability using automation, using AI, using all of those advanced algorithms that we can push into the brains of these systems. So you can see the different kind of mission sets around the side of that circle that it enables, but really that was the point of pushing all of the unmanned and unattended sensors or unattended systems down to us. That is my last slide. I wanted to kind of give you an idea of what I do now. Like I said, I'm 50 years old. I'm working on 30 years in government. I ran quickly through my career. I consider myself to be extremely fortunate for the career that I've had. I'm extremely lucky for the opportunities I've had and the things I've gotten to work on. Spending time out on board ships, doing missile flight testing, riding in tanks that float on the water and go 30 knots and shoot 30 millimeter guns. Not something everybody gets to do every day. And then working down here at Special Operations Command, I get phone calls on a regular basis from operators around the world asking for us to help them do their job better, and we're able to quickly turn things. I'm a GS-15 right now, so I'm a equivalent to a military 06, which would be a colonel in the Marines or the Army or the Air Force, and a captain in the Navy. And traditionally, if you work for the Army or the Navy or the Air Force, to have my level of responsibility and my level of control that I have here at Special Operations Command, you're probably going to be a 2-star general somewhere. Like I said, I have full authority. I'm the milestone decision authority for all the programs that are in my portfolio. It's just not a level of autonomy and control that it can find at other places. But to have that progression in my career, to start when I was 16 years old, to do it through college, when I was going to Virginia Tech, and then be able to come out of college and step right into it. I find myself very fortunate for the career that I've had, and I've been asked several times, when are you getting out? And to be honest with you, my wife has said, you could make a whole lot more on the outside if you went to a private company. And I tried. I did 2 years. Like I said, I had a 2-year break when I first came down here, working not for the government, and I just didn't have the level of responsibility. I didn't have the level of authority. I didn't have insight into all of the things that were going on. The job satisfaction that I get out of what I've done over the last 30-ish years, I don't think could be topped. Eventually, I'll get out. Eventually, I will stop doing what I'm doing. I got to make room for those who are coming behind me. But I'm in no rush. I'm not chasing after money. I'm in no rush to leave what I'm doing now. I'm having an exciting time. So I hope that this was informative, and I'm open for questions if anyone would like to ask me.
Yeah, thank you so much, David. Yeah, we're going to open the floor up for questions. We've got about 10 minutes left. So if you would like to either raise your hand, or if you feel more comfortable, you can type out questions in the chat and we'll read those out. So yeah, any questions? Yeah, go ahead, Adam.
Thank you so much. That was super cool to hear about. I'm interested because you started off more on the technical side and now you're a leader over a lot of things. I'm interested what your thoughts are on that, like your job satisfaction when you went from technical to leadership. And do you sometimes miss being on the technical side? Do you still get to do some things with that? Or what are your feelings on that now?
Yeah, I do miss it. I'll tell you, the most exciting part of my career was probably when I was an engineer with the Navy, working the ballistic missile defense stuff. Just because I would be out on a ship, you're getting ready to do a missile flight test. It's hard to fathom the amount of resources that it takes to actually just coordinate one of these flight tests. And so, if one of the systems that you're responsible for goes down, like a half an hour before they're supposed to shoot this missile, you are scrambling. And I've been on ships, just doing quick, wire splicing, cutting things, taping things, duct taping things, putting stuff together and back, and just like holding things together and just praying it was going to work. So just a lot of fun, nerve wracking, but a lot of fun. A lot of the technical stuff. Got to work in a lab doing kind of cool stuff. So that was great. And I never imagined that I would have kind of gone from the engineering discipline into program management. I think it was the right progression. I don't regret making that progression. The folks that I hire and kind of try to attract into what we're doing now, you can make an engineer a program manager. You can never make a program manager an engineer. And it's really just kind of about, drive and willingness to learn, and, how much do you like the job type of stuff. I do get the opportunity. If you look at the portfolio, I've got about, I'm trying to remember exactly how much. I've got about a $200 million R&D budget a year. And so we do spend quite a bit of time on research and development and engineering development. And I do sometimes get the opportunity to nerd out a little bit and get in a room and have a critical design review for a system that's in development. Got a lot of smart people working for me. So I do still get the opportunity to kind of dip my toe in there. It is a perishable skill, so I can never claim to be, the smart guy in the room anymore, but I get to hear the smart guys. So I am lucky enough that I'm still surrounded by kind of that engineering stuff while I stepped away from it in my own job.
Awesome. That was a great question. Yes, go ahead.
Hello. Let's see. I'm new to tech, very, very new to tech. But as I've pushed forward through my master's in information systems management degree, I noticed there's like so many different incremental things that I want to bring value to. But even though I'm so new to it, this is one opportunity I saw in my email. I was like, oh man, I really want to be a part of this. So I'm definitely open to it. What are the, I guess, what are the steps to moving in this and really learning more about the opportunities that you do have available?
Yeah.
So I'm not sure for me, or is that a question for Bill or Molly?
Yeah, I think that's more a question for us. Yeah, I think the best way is to contact Jesse or Markham. They're gonna have the best information for you on job opportunities that are currently available that fit your skill set. They'll talk with you about your graduation date for your master's and stuff like that, and where those skills can be applicable. So yeah, their emails are in the chat. So I would definitely reach out to them, set up an appointment. They'll talk with you one-on-one and be able to give you a lot more information. Yeah.
Okay, absolutely. And this is an exciting opportunity to definitely be on this call and be a part of this. So thank you.
Yeah, thank you. That's what we're here for. All right. Any other questions?
I don't want to step on anybody else, but I want to do a filler here real quick. Throw David one. So David, you talked a little bit about, early in your career being at Naval Surface Warfare Center, Dahlgren, right? And that's one of the things that we work hard at AI Futures is to partner with a lot of those research labs across the DoD, because that's where a lot of the employment for these folks is going to happen, right? Can you talk a little bit about how, you at SOCOM, especially in your PEO, really partner with some of those labs across the DoD to bring tech and defense industrial base too, obviously, but just kind of how you reach out into those, into that whole world of research lab to really empower the technology that's coming to you.
Sure. Yeah, that's great. If you look at what the budget is for SOCOM, for Special Operations Command, compared to what the larger defense budget is, and I can't remember the actual percentage numbers, but we're a very small percentage of what the larger defense budget is. We think we execute on the order of $13 billion through the acquisition center here, which is peanuts compared to what is available across the department and across the national lab infrastructure. And so we have no choice but to rely on partners across the federal government. And that includes, if you look at, and I actually did a paper for this in my second master's up at National Defense University on what the S&T and R&D infrastructure is across the country, including service labs like the Air Force Research Lab or Navy Research Lab, ONR, or the national labs like Sandia National Lab, Los Alamos National Lab, Pacific Northwest National, right, Oak Ridge, all those. Their budgets are orders of magnitude bigger than SOCOM's budget. So I have partnership agreements and contracts. Number one, Johns Hopkins, like I mentioned before, the University of South Florida here in Tampa, we actually put a contract in place with them because they now have, they are part of a consortium of different research universities that we can tap into to not only have them do some research for us, whether it's their students or they will actually hire. And we can get students I have students working on some of my small sat projects there at the University of South Florida. I actually have my ground station in the University of South Florida that's some of their students are working on and with us things like operating their satellite. Across AFRL, several projects across AFRL, but also reaching into the national labs. Los Alamos National Labs actually built and helped us launch our first Cube satellite. I've got Sandia National Labs working on similar projects now. But like I said, I think my own R&D budget is about $200 to $250 million a year. It sounds like a lot. Like I said, I kind of have to remind myself that this is a lot of money when I start talking about my budgets. But compared to what else is out there, what that does is it really gets us a seat at the table to be able to work with other partners across the kind of R&D infrastructure across this country.
Dave, is that paper that you did, is that public domain? It'd be interesting to push that paper out.
Yeah, that's a good question. Let me check on that. It probably is, because I'm sure National Defense University has it published in their own archives. But let me check.
Okay, cool.